All right, so we just went through the main C++ containers and talked about the big O of various operations within the C++ containers. So we learned so much, right? So we went through vector, queue and stack, map and set, and we also covered the unordered map and set. And we went through and talked about what the big O is for each operation. And do keep in mind that some of the operations don't really make sense. And so I kind of talked about them in the lectures on those types of containers, but some of them are just like, it's not really possible, or it doesn't really make sense. So for example, accessing into a set and a map, you can access into it by doing like a key lookup, or, accessing something into a set, but it's not really access in the same way that it is for a vector, for example. The whole idea of a vector is that you get direct access, or a stack or queue get direct access to the top or the front. So you don't have direct access to maps and sets, and so we can kind of say that that is like a not applicable thing. But otherwise, these are all of the operations that we talked about. So just a reminder that we aren't going to be using the unordered maps and sets yet, but all other are fair game for what we're working on in class. The unordered we'll be using later. So what are they good for? So vectors are really good for simple storage. They're easy to use. They also maintain the order if you need to place data into a structure that has, maintained order. So meaning the order that you want it to be in. You also can have direct access to a vector. So again, if you need direct access to something, the vector is really the only option, right? So if you need to randomly pick something, or pick something specific from a data structure, the vector is your go-to. Vectors are not good if you need to like change storage or move it around a bunch, because it's pretty expensive, because they have an order, right? And you have direct access to them. So those are the pros and cons of vectors. Stacks are first in, last out operations. They're really good if you need to like reverse some data. They're not good for most things, meaning they have kind of like a niche area of when you would use them. So they're not like a general purpose, container, but they're used all the time in algorithms. You're going to be using them in lots of algorithms you're writing for the next project and for future projects. So they're super useful, but they don't have there's not like a lot of different things they're used for. They're basically used if you need to place something in and you want to access them in the opposite order that you originally got them to, if that makes sense. Queues are first in, first out, so they're really good for scheduling. Like if you want to keep something in the order that it was received, then you want to use that. Again, not useful for most things. There's no direct access. They're not good for search. They're not good for like printing stuff out. So stacks and queues have this like really specialty area. Sets, on the other hand, are good if you want to keep unique sets of things in your code. So because they don't allow duplicates. And that's really all they're used for. Is if I think I gave this as an example last week when I talked about sets. If you're like thinking about like a problem on like a Google map and you don't want to revisit somewhere you've already been, you can imagine a set would be great for that, because every time you've been somewhere you put it in the set and you never go back to anything that's in the set. And it's really fast because it's really easy to tell in a set whether you've been there or not, because it has really fast lookup. But it's not good if you need to directly access by index. It's not good if you need to be able to have any order to your data, because it removes all the order and it only keeps track of like the value. Maps are also really good for lookup. They're also unique, so you can't have like duplicate keys. There can only be one thing associated with one key. So in the same way that sets are unique items, the keys in maps are also unique. But maps have key value pairs, and they're really, really good at lookup and search. So if you need to be able to access something quickly, a map is the thing to use. but they're not good if something needs to stay in order. They're not good if something yeah, so they're not good when order matters, is really the only downfall of a map, because it maintains a specific order, which is the order of the binary search tree, which is typically a sorted order. And we talked about both sets and maps having this other unordered container option, and those even have less order associated with them because they're not even in sorted order, but they're faster. So maps, really, really good for lookup. That's what you want to remember. If you need to be able to retrieve something fast, a map is the one to use for that. So that is it for our C++ containers. And that's it for the content for week 3.